Hello, grade 9s, and we are busy at my school with simplifying expressions using factorization. Something I know you all love, and by now, when you haven't listened in class, this is what I'm noting in my class. All of a sudden, the kids are scurrying around, looking, trying to figure out how to factorize, because they can see this is not just a small section, it's here to stay. And I will need to know how to factorize. So please, if you don't know yet, please do look at the videos and get to know how to factorize your three different types of main factorization: HCF, difference of two perfect squares, and the good old trinomial. All right. So at the end of the section, this is why we factorize. We want to teach you how to factorize so that if I've got multiple terms, instead of splitting it, remember in grade 8, you used to split it. Let me just do this. And now I've got the wrong pen here. Okay, so you used to say 8x over 4 plus 4 over 4. Are you still allowed to do that? Of course you are. But sometimes it's just easier. Yeah, sometimes you can't. Because it doesn't take you anywhere. You know, it's sort of like after doing this, you can't simplify any further. So 8x divided by 4 is 2x plus 1. So are you welcome to do that? Yes, if you can, and you can see, well, it's an easy way, quick way to do that. Yes, but we mainly use factorization. All right, another thing I want to show you. Why do we factorize? So if I've got 10 plus 2 divided by 2, I cannot just go and cancel like that. No, because the answer is not 10. Because in fact, 10 plus 2 is 12. 12 divided by 2 is indeed 6. So please, that is why we factorize. So that I can take out a highest common factor at the top. What is left? 5 plus 1 over 2. Then I can go and cancel out. Why now? Because I've got one term divided by one term. Then you can cancel out. And then you get your answer, which is 6. All right. So just a quick way again, why do we factorize? But you'll see that in my videos I explain quite nicely. All right. And these are the sums that I gave to my students today, just to make sure that they understand how to use the factorization and simplification. This is what we aim to do at the end of our section of factorization. Okay. So can you see with this one? It's already one term. So I can just go ahead and divide out what I can. The two x's can cancel out, and 5 over 10 simplified is a half. All right. Oh, these huddy-does. They love to shout at me. All right. I'm going to take out a highest common factor. Please, people. Oh, today in class, some people wanted to take out an 8. Some people wanted to take out the 2 only. You have to take out the highest common factor that you can take out, that when you divide it out with these two terms over there, that you get left with beautiful whole answers. Okay, so if I take out a 4, 8x divided by 4 is 2x, plus 4 divided by that 4 is 1. So that if I distribute it back, I get my original expression over there. And that was over 4. And now the two 4's can cancel out. And I've got 2x plus 1. Okay. So I'm going to identify over here. This is a difference of two perfect squares. This one is an HCF. Why is it not a difference of two perfect squares? It maybe looks so nice, but can you square it too? No. Can you square an x? No. Okay, so don't. All right, difference of two perfect squares. You've got two brackets. That's exactly the same, just with a plus and one with a minus. Okay, the square root of x squared is x. The square root of 4 is 2. And over here, I'm going to take out an x. What is left? X minus 2. So those two will cancel out, and then I've got x plus 2 over x. And then some people will go and say, oh, the x's cancel out, it's 2. No, 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 no. Why? Because it brought me back to 2 terms. I've got now again 2 terms divided by 1 term. So I cannot divide out. If I could take out a highest common factor over x, but I can't because there's no x over here by the 2. So that's where your answer stays. All right. Identified. It's a trinomial. HCF. All right. Let's factorize this bad boy. X and x. They are the same. They both negatives. Please get that right now. Okay. In the class today, some students used 6 and 1. But when you test yourself, -6 minus 1 should give you this -5. And it doesn't. Okay, so we will have to go and use the other 2 factors of 6, which is 3 and 2. Okay, -3 minus 2 does give you that -5. All right. Over, this was an HCF. I take out a 2. What's left? X minus 3. Now I can go and cancel out those 2 brackets. And what is left? X minus 2 over 2. Am I allowed to go cancel out those 2's? No. Why? Because I've got 2 terms at the top. Goody. What is that? Difference of 2 perfect squares. What is that? It's a trinomial. Okay, you need to start recognizing them. Easy peasy. Okay, 2 brackets with a plus and a minus. The square root of x squared is x. The square root of 9 is 3. At the bottom, 2 brackets. My signs are the same. What are they? They're both negatives. And what times what gives you 9? If you add or subtract, gives you 6. It's 3 and 3. Now, very important. You cannot go 1, 2, 3. No. It's 1 for 1 cancelling. So I can only cancel 1 on top with 1 at the bottom. Not somewhere 1 with 4 or 1 with 3 or 1 with 2. 1 for 1. And that is what I'm left with then. Are you allowed to keep your brackets? Of course you can. Are you allowed to drop it? Of course you can. Okay, because they're on top and at the bottom together, they are sort of in a bundle, and they'll always stay a little bundle key, but you are allowed to bundle them up in the brackets. Okay, we've got trinomial. We know how to do these trinomials. X splits, they are different. Different meaning plus, minus, minus, plus, but which one goes first? The minus. Oopsie. Patati. X minus plus. What times what gives you 12? 4 and 3. Just check it. Minus 4. Sorry. Minus 4 plus 3 does give you -1. And if you multiply, it does give you 12. At the bottom, the x splits. They are the same. They are both positives. And what about, okay, now 6 times 2 won't work, 4 times 3 will work. 4 times 3 is 12, plus 4 plus 3 does give you that positive 7. Okay, cancel, and I'm left with x minus 4 over x plus 4. Just a quick look at 2 little bit harder ones where we've got a multiplication. Now, what you're going to do is you're going to factorize where you can. Then we're going to cross cancel or cancel top and bottom, but never upstairs and upstairs and downstairs together. Okay, so if you don't know what the heck I'm talking about, let's see. So I'm going to factorize the top over here. X squared plus x. Can you see there's a similar x? There's a common x in both. So I'm going to take out a x. What is left? X plus 1 over x multiplied with x to the power of 3. And that, boys and girls, is a trinomial. Oopsie, the x goes in and splits. They're the same. They're both positive. And 1 times 1 gives you 1. And if you add 1 and 1, gives you 12. Okay, so now we're going to cancel where we can. Aha, these two x's can cancel out nicely. We can cross cancel with x plus 1. The only way, I just want to make sure that I've done this correctly, x and then x plus 1 times x to the power 3 over x. Yeah, okay. Some students in the other class had an x squared there, unless I just said over x. Okay. Then, what is left over here is x to the power 3 over x plus 1. Okay. Easy peasy. Very good. All right. Let's look at this one. Oi, oi, oi. It's hectic, but it's lovely. Let's do this because we can. This is a trinomial. This is an HCF. This is an HCF. This one, can you guess it? Yes, you can. Difference of two perfect squares. Okay, let's start with the top. It was a trinomial. So the x splits, they are different. Plus is the first one. And what times what gives you 6 if you add or subtract? 3 and 2. Plus 3 minus 2 does give you that positive 1. Over here, can you see there's a common x? And I can take out a 3. So 3x, and what is left? X minus 4. Okay, so just check yourself. 3x squared minus 12x, that's correct. Now, with the divide by sign, we don't divide. We just want to multiply. So what happens? You say, okay, I don't want to divide. I'm going to multiply. So I times and I tip. So whatever is to the right of that times sign that you've changed, the bottom goes and stands at the top. So let me just rewrite this. I'm going to factorize now again. And the things at the top goes and stands at the bottom. Times 1 over x plus 4. And whatever is after that stays exactly as it was. It's only this part over here that changes. So you times and tip. Okay, let's keep on factorizing that middle term there, or that middle x part. X plus 3 times x minus 2 over 3x. I'm just rewriting this. Times. Okay, there is a difference of two perfect squares. And that is an HCF. I'm going to take out x squared. What is left? X minus 2. You can check yourself if you had to multiply it in. Does it give you this part over here again? X to the power 3 minus 2x squared. Yes, it does. Times 1 over x plus 4. Oh, I don't know if you can hear my daughter coughing. She's been sicky. Shame. Sorry about that. Okay. So now I can go and cancel now. Now I've got left all the wonderful things. So I can cross cancel. Let me do that. I can cancel like that. I can cancel upstairs, downstairs, but I can never cancel sideways like that. Okay. All right. Okay, so now I'm going to start. Here's the x minus 4 and the x minus 4. Bundle that together because it's alone there. You can x plus 4 and x plus 4. X minus 2 and x minus 2. So now I'm just going to bring everything together just to see that I haven't missed anything. At the top, it's x plus 3 times 1, which just stays an x plus 3, all over 3x times x squared. Okay, so you see it's 3x times by x squared, which will leave me with x plus 3 over 3x to the power of 3. Okay, there's no way of factorizing that further. There's no HCF there. So that is your answer. All right. Okay. Oh, thank you so much for watching. I hope really that it helped, and that you are confident with your factorization, that you can see it like I see it. HCF, difference of two perfect squares, highest common factor, because next year in grade 10 you're going to build onto this, and you're going to learn about a few more types of factorization, a little bit harder, so that this has to be solid in your head. All right, especially if you want to go all the way to matric. Okay, thank you so much for watching, and I hope you have a wonderful day further. Thanks, bye.